right, ladies and gentlemen, I want to say a big welcome to all of you in the middle of the thick forest along the route where ancient travelers of the pre-vehicular era trudged, trundled, and tottered their way to the big town. It's nice to have all of you here. My name is Dr. KOA, and I want to welcome all of you to the Valley of the Shadows of Statistics for Business Analytics. It will open your mind. My goal is to help you if you want to be helped. I'll address most of your questions based on you typing the questions in the chat or raising your hand and then, addressing your questions. But you want to use typing your questions most of the time in the chat. Okay. For those of you who do not know me, my area is mathematics and economics. My first degree was in the University of Ghana. I had mathematics and economics 3.97 GPA. I did quite good, valedictorian. My master's was in Loughborough University, where I did financial economics. I was very good. I know I should know, you should know that you are good if you are good. I did my PhD in Warwick University, operations research and management science, particular emphasis on mathematical programming. And then I did my master's again in MIT, where I did decision science and machine learning. So, yes, I'm a visiting professor in Johannesburg University, Leicester University, De Montfort University, Warwick University, and passionate about my labor. So it's nice to have you and to have all of you. Please feel free. Ask me as many questions as you can. That's the only way I can dig into you. Let's set the ball rolling. I'm the module leader for this. I'll be assisted by Abeku and Hanan. They will be helping in the process. So what is our goal today? My goal is to help you understand the basic concepts and principles of data analytics, using statistics and applying them to business analytics. Now, data analytics is more or less in the computer science and mathematics department, data analytics or data science. But business analytics is more in the business school. So within the business school, you normally hear of business analytics instead of data science or data analytics. My goal is for you to understand why we need statistics to push business analytics. My goal is to help you understand and elucidate the types of statistical methods, the types of data, and the scale of measurement. And today, I will help you to construct, interpret the distributional plots to make an informed decision. But more importantly, I will help you to use Excel to generate and interpret descriptive statistics. Feel free to read any of these textbooks. Anderson is key. Heman is key. Evans is super. Modern Analytics and Feature Quality and Performance. This was the first paper published in Quality Management Journal. If you are not that good in Excel, I have put a video here that will help you on everything you need about basic Excel. Check it. I've also put some data sets here. But there's a free data analytics software, which is an add-in in Excel. You will love it. You will love it. All right, so let's start with this module. The essence of this module is to do 3 kinds of analytics: univariate, bivariate, multivariate. And then we'll go deeper into regression, classification, time series, and cluster and factor analysis. Okay, but here is where I want to start with you today. What is data? So many people don't know what data is. They confuse data with information. By the time I finish explaining what data is to you, you have to tell me the difference between data and information. By the way, data is oil. Artificial intelligence is the new electricity in town. Data is so much now. Netflix is dealing with lots of data. Google is dealing with lots of data. Social media, Facebook, Instagram, Twitter, all of them are dealing with hundreds and millions and trillions and pentillions of data. Data is going to be the new oil. A time is coming in the world, the quantum of data you have will determine your net worth as a country or as a person. So what is data? The facts, the figures that you collect, you analyze, you present, and you interpret. The facts and the figures. Now, please note this, that data is not all about numbers. Data can be pictures, audios, videos, digital files. All of these are data. For example, your name is data, and your age is also data. So what then is the difference between data and information? Who can tell me? What is the difference? What in your mind, in your current mind, whether you know or you don't know, what is the difference between data and information? Who can tell me? Who can raise a hand and tell me something? Tell me something. Tell me something without Googling it. What is the difference between data and information? What is the difference? What is the difference between data and information? I must have a smart person in this room. At least one person must prove to be smart. I cannot have all of you not being smart. Okay. Tell me your answer. And the thing is that there's no right or wrong answer. So let me go to John Kingsford. John.
Yeah, good morning, Prof. Hope you can hear me.
Yeah.
Yes, so to the best of my knowledge, data being facts and figures collected, the difference between data and information is processed data or data that has been worked on. Whilst data can be just a group of figures, numbers, pictures, videos, every other thing. But information is a processed data that brings meaning to whatever we are talking about or we are analyzing.
Very good. I love that. I love that. There's a word you used. I'll come back to that word. Let's go to Afia. Oh, by the way, whenever you're giving a comment and you feel like you want to show your face, please do. Afia, I've indicated you to unmute yourself. I don't know what's happening. Okay, Afia, unmute yourself and let me see. Unmute yourself. Unmute. You will see unmute there yourself. I've allowed you. Yeah, go ahead.
Okay. The data comprises of the raw or unprocessed facts. And it can be useful though.
Is it coming from your head?
Yes, please.
Okay.
Yeah, but the information is it's like data that has really been processed. Like you've organized it in such a way that you can use it to do any kind of interpretation, take any decision, and at the end of the day, the information that you get, you can get some kind of values to interpret things with.
Good. At least you've said some. It's a bit of a repetition of what John said. And I'm reading the point made by Bruce and Samuel. It's all good. So basically, data is information that is not meaningful. Information is meaningful data. That's cool. Information is simply meaningful data. There is some meaning to it. So anytime you collect data, don't say that I have meanings to it. You can collect data and you will not make any meaning from it. I can look at the data and make some meaning from it. All right. And when you take data, there are elements in the data. So when you collect the data, there are elements. For example, you will have name, a column called name. And in that column, you will have Afia, you will have John, you will have this, you will have that. Okay, that is what is known as elements, the elements. Now, what then is a variable? A variable is one of the features of the data that you want to look at. Okay, so let's say that you have a column called name, but you have a column called age, and you have another column called height of the person. You have another column called educational level of the person. These ones are called the features or the variable of the data. So let's put the two together. What is statistics? Because the essence of our presence here today is statistics for business analysis. Well, what is statistics? It's a science. Take note. It's a science, is the skill of collecting, analyzing, organizing, analyzing, presenting, and then making sense of the data in order to make an informed decision. That is statistics. And so we will be dealing with data a lot. That's all I'm trying to say. We'll be dealing with a lot of data. You already have some data on diabetes. We'll be dealing with it. Let's look at one data. This is data set for 25 mutual funds. The fund name are on the far left: American Century Tax-Free Bond, Artisan Small Cap, and all of that. Then you have the type of fund, the net value, the 5-year return. Okay. You have whether it is domestic or not a domestic equity. You have the expense, a Morningstar rank. All of these are information. And when you look at some of the information, they are numbers. When you look at some of the information, they are not numbers. Okay, we'll come back to that. What do we call those that are numbers from those that are not numbers? We'll come back to that. But this is a typical example of data. Here's another one. Now, this data is a bit different because the numbers are fewer than the letters. The letters are many. These are the working classes of people. These are the ages. The first column is the ages, then the working class, the educational level of the people, the marital status of the person. Okay? Then you have other things, including occupation, gender, hours per week, income level, and everything. This is another kind of data. We can make a lot of sense from this data. You can use this data to make a consultation for a company. You can use this data to become a consultant and make hundreds of thousands of dollars because you understand analytics. This is another one. This is the one that we are going to use today. It has to do with the information. And by the way, I've given you the Word document regarding this data. Okay. What is it about? Well, we know that diabetes is one of the most frequent diseases in the world. The number of diabetic patients are growing every year. And it's said that the main cause of diabetes is clearly unknown, yet scientists believe that there are some hereditary or genetic factors involved. There are also some environmental lifestyles that play a major role in diabetes. Now, let me tell you some secrets. A few years ago, a research was done on the tribe in America. The name of the tribe was called the Pima tribe. It is also known as the Pima Indians. Now, in this tribe, it was found out that ladies are prone to diabetes very early. Ladies. So this data you're having here is ladies. Now, a lot of restrictions were placed on the selection of the instances from a larger data set. Particularly, all of the ladies, the patients were females, at least 21 years old among this Pima Indian heritage. So in this data set, we are going to analyze different aspects of diabetes among this Pima diabetes group in India. And the first thing we will do is something called exploratory data analysis. So when you look at this data, you have the attribute information. You remember, they are all women. So that's why we can talk about pregnancies. So pregnancy deals with the number of times the woman has been pregnant. Can you imagine some of them have been pregnant 10 times? Like this number 9. Oh, 10 times. A person has been pregnant. Opele. Pregnant 10 times. Okay. And then you have glucose. Glucose here deals with the plasma glucose concentration. At 2 hours in an oral glucose tolerance test. So That is the kind of quantity of glucose in the woman. Then the blood pressure level of the person. And here we are more interested in the diastolic blood pressure level. And then the thickness of the skin. Triceps, skin fold thickness, which is measured in millimeters. All of these are. Then the insulin level, the 2-hour serum insulin test that a person are taking. The body mass index, that is the weight in kilograms divided by the height of the person square. That is what you have here. The diabetes pedigree function is also there. Normally, the diabetes pedigree function is a function that's called the likelihood of diabetes based on the family history. Then you have the age of the person. Some of them are 50 years. And look at the person who has been pregnant 10 times. That person is how many years old? 29 years. Oh, the person who has been pregnant 10 times is 29 years. And the person who has been pregnant 54 times is 8 years. Anyway, that's interesting. The final outcome is a categorical variable. As you can see, outcome. The outcome here is 0 if the person is not diabetic and 1 if the person is diabetic. So you can see all of this here. Now, this is data. Let's try to understand what business analytics is before we can connect statistics for business analytics, guys. We know, as of today, according to Evans and his book, that business analytics, and the reason why we call it business analytics is because we're in the business school, is when you use data, information, technology, statistics, quantitative methods, mathematical and computer-based models. When you use these things to help supervisors, managers, government to get an enhanced insight, understanding about their businesses so that they can make an informed decisions. It's a very powerful thing. It's growing. It's growing. Now, what is the connection between artificial intelligence and business analytics? Well, business analytics encompasses artificial intelligence. Artificial intelligence, within business analytics, you will use several things within artificial intelligence, within machine learning, deep learning, robotic engineering, computer vision, cloud computing. All of these, you can use that within business analytics. So the science of transforming data into realistic insight, that is business analytics. There are 4 kinds of them: descriptive, diagnostic, predictive, prescriptive. These are the areas of, and my goal is to use statistics to address each analytic. I'll use statistics to deal with descriptive. I'll use statistics to deal with diagnostic. I'll use statistics to deal with predictive analytics. I'll use statistics to deal with prescriptive analytics. Now, of course, statistics is just one of the things you use to handle each one of these. There are other things you can use to handle each one of these analytics. But our purpose, we will use statistics to deal with each one of these. So what is statistics? Why are we using statistics for analytics? Well, we know that the past, the present, and the future of conditions, whether small conditions or big conditions, okay, statistics can be used to describe those past. You can use statistics to collect and analyze data. You can use statistics to make an informed decision. You can use statistics to communicate your findings to people. And that means that you need to know the methods within the statistics. Statistical methods are important because they will allow you to get a richer understanding of the data. They go beyond business intelligence, okay? Like reporting, accounting reporting, and database. No. They go beyond that. They are not only summarizing your data for you, they are precisely, finding unknown matters, connecting information, the statistical relationships, And we are going to look at some of these statistical methods to address some of, like descriptive analytics, this exploratory data analytics, estimations of statistical works, inferences through hypothesis testing, more advanced ones like regression, forecasting, data mining. All of these are some of the statistical approaches we will use. So let me just give you a few of them. There are 4 types here. Classification, ones. Within classification, what you are doing is that you are separating customers, into appropriate groups based on their characteristics. So for example, if you look at Amazon uses classification approach to detect which customers like electronics and which customers like clothing. Okay, so you will notice that they will be able to use this to segment customers into those that are long-term customers, medium-term customers, and then short-term customers. Classification is very important, and there are tools there that can use that. The other one is pattern recognition. Pattern recognition is simply, using machine learning algorithms. The word algorithm simply means procedural analysis, step-by-step analysis. That's algorithm. And then you can use this to recognize patterns, similarities, regularities, irregularities in a data. Whether the data is a text, is an image, is a sound, is a video, you can use the pattern recognition to detect. You can plot the data using histogram. You can plot the data using box plot, scatter plot, and other visual analytics. And they will help you. Okay? Not today, but going forward, we shall use some of these things to do pattern recognition. Another statistical method is association. You can use it to determine which items go together, which ones are connected together. You want to detect the relationship between certain things. For example, what is the relationship between price and quantity demanded? The higher the price, the lower the quantity demanded. And what is interesting is that you use something in machine learning called recommendation systems. That is what Netflix uses. Whenever you watch a comedy, Netflix will see that you like comedies. So the moment you finish that, it will give you similar comedies. Sometimes they will tell you that people who watch this movie also watch this movie. It's called recommendations. It's a technique. You've set it up already. There's nobody controlling it. And automatically, it gives you, those things. So if, for example, if you take, this is one of the association learning rules at the bottom here. If a person should buy maybe this particular food, let's say you go to the shop, the moment the person buys bread, is likely to buy sugar and milk. So they have arranged the milk, the bread, and the sugar all around the same area. So it's not like you go and buy bread here in this section of the shop, then you move and go and buy, another one in this other section. No. This is associated. They know that they move together. 93% of people who buy item A also buy item B. So we'll group them together. It's a powerful statistical approach. And finally, predictive analytics. So this one, you can use it to predict the future. For example, what is the probability that this customer will not pay the loan if we should give him the loan? What shows he will not pay? You can use logistic regression, decision trees, random forests, neural networks, naive Bayesian statistics. Okay? And you can use this to address some issues. For example, fraud detection. The ability that there's a fraud going on in this particular transaction. You can use that. Credit card loans. What shows that a person will pay? Okay. Credit risk assessment. What shows that the person will be able to, handle this risk in that context. So you are able to use this predictive analytics to handle. Ladies and gentlemen, how do you do data analysis? Well, first you need to understand the business you are dealing with. Then collect your data. Pick the sample, model, and then analyze the data. check the data. Model checking is very good. You do a lot of hyperparameter tuning, and then finally you write your everything into a report. Some of them require a lot of programming skills. Some of them is just your knowledge. For example, some of you are from health. Some of you are from finance. Some of you are from politics. Some of you are from other areas. So that means you understand your area. So the first one is you understand your area, but the other ones require you to know how to do programming. That is why you are also doing programming. Okay. Now let's look at data types. There are types of data that will help you a lot to do your work. You see, I'm trying to move closer to you doing the Excel. So please bear with me as you do. Now there are two kinds of data. We call it qualitative, quantitative, categorical, numerical. I know you've learned this thing somewhere. Can you confirm whether you've learned this thing somewhere? Can you type it there, whether you've learned qualitative, quantitative, categorical, numerical somewhere? Anyway, if you haven't, here is what it is. Qualitative data deals with letters. Selassie says yes. Okay. Who else has? Qualitative data is the same as categorical. Categorical means that they are categories, they are groups. They deal with letters, English letters. Numerical deals with numbers. This is called data type. It's not the scale of measurement, it's the data type. Or most of you have done it, good. Once you have data, from data you can have information. From information you have knowledge. From knowledge you have wisdom. What is the difference between knowledge and wisdom? Who can tell me? What is the difference? Because you have to have an information and then you have knowledge. What is the difference between knowledge and wisdom? Knowledge and wisdom. The wisest man who ever lived is King Solomon. Yeah, John, what is the difference?
So wisdom is the application of knowledge.
Good. So can you be a knowledgeable fool?
Yes, you can.
Yes, you can. You can have the knowledge and you still be a foolish person. How? Well, the thing is that the computer is also knowledgeable, right? If you ask the computer, what is 258 times 72? The computer will give you. That doesn't mean that the computer can make sense of that. Now, if you have so much knowledge, like a doctor, a professor, and you don't put that knowledge to practical use, you are foolish. I'm not the one saying it, it's King Solomon. Why? Because wisdom is the application of knowledge. Wisdom is knowing the obvious when it remains a secret. Wisdom is the ability to see the unseen when others think it is a secret. So you can be a professor with so much knowledge, but that knowledge is not helping you make practical decisions that help you in your health, that help you in your family, that help you in your finances, that help you in your relationship with others. And therefore, even though you have the knowledge, you are a knowledgeable fool. There's a professor in France. He said that a learned fool is more a fool than an ignorant fool. Did you get it? A learned fool is more a fool than an ignorant fool. By the way, I've allowed you to unmute yourself anytime. So if you are learned, now the reason why a learned fool is a bigger fool than an ignorant fool is that a learned fool has put in time, money, and effort. The ignorant fool has not put in time, money, and effort. If you tell me you are learned, you've put in a lot of time, money, and effort, and yet you're a fool. And me, the ignorant person, I've not put in time, money, and effort, and I'm also a fool. So who is more a fool? Knowledge is useless until it's used. That's very powerful. Anyway, so yes.
Can we add that application of knowledge, even at the wrong time, still makes one unwise?
Yeah, I agree. I agree. If you have learned how to throw bombs, okay, and you go to a supermarket and you start practicing that throwing of bombs, you are doing it at the wrong time, at the wrong place. You're a fool. You see, people see foolishness as, when you tell somebody you are foolish, the person takes an offense. But foolishness is inside everybody. Foolishness is the abandonment of the truth. If I were to take you through the levels of knowledge, guys, you are not going to finish today. Okay. On the spectrum of knowledge acquisition towards wisdom, the lowest form of knowledge is assumption. The highest form of knowledge is imagination. And foolishness is when you abandon the truth. But ignorance is better than foolishness, because ignorance is when you are aware that you don't have the truth. Ignorance is when you are aware you don't have the truth. So you are ignorant. Doesn't mean you are bad. You simply acknowledge you don't have the truth. Then you go to the next level, which is knowledge. Knowledge is accumulation of the truth. By the way, when I say truth, what is truth? Truth is self-evident reality. Then from knowledge, you go to understanding, because you can have knowledge about something when you don't understand. In the army, they will tell you shoot, and you shoot. You don't even understand why they said you should shoot. So understanding is the assimilation of the truth. Understanding, that is assimilating the truth. Then you go to the final level, which is wisdom. Wisdom is application of the accumulation of the knowledge of the truth. And accumulation of the truth is actually knowledge. That is why I tell you, my own definition of wisdom is wisdom is the ability to know what is obvious, even when it is a secret. Let's move on. That's for another day. When I'm in the mood, I'll finish you guys. Now, there are 4 kinds of scale of measurement. Qualitative has 2, quantitative has 2. Nominal. Nominal data is that kind of data that is based on names or labels. For example, there is no meaningful, ranking attached to nominal. Take note of that. See, don't only listen, write things down. Nominal has no meaningful information. Okay. For example, when I say man or woman, this is gender, male or female. There is no ranking. You can't tell me that male is better than female or female is better than male. There is no order of importance. Application status, there's no order of importance. When something is red and I give it a value of 1, and something is green and I give it a value of 2, it doesn't mean that the 1 is first and the green is second. No, there's no meaning. If I ask you, where do you live? You say, I live in the north of the equator, the south of the equator, neither of them. There is no importance. That is nominal. Ordinal, there is importance. There's some ranking. There is some ordering. There is some meaning. For example, if I look at fresh credit rating, okay? If you look at the grade of a class, somebody has A, somebody has B, somebody has B plus. All of these are meaningful because A is better than F. It's not like religion. You can't tell me that Christianity is better than Muslim, or Hinduism is better than Buddhism. That is nominal. That is nominal. But ordinal is when you have things like excellent, very good, and all of that. If you take university degrees, bachelor, master's, doctorate, these things are ordinal, even though they are in English, because you can rank them. Professor, associate professor, emeritus professor, TA, senior lecturer, all of these, you can rank them. So they are ordinal. The word ordinal comes from the word ordering, order ranking. All of them are dealing with letters, qualitative. But that is not the same as quantitative one. You see, the quantitative one, there are 2 of them, interval and ratio. Interval is where the data is showing the characteristics of ordinal, that you can use numbers. Let me ask you guys a question. Who can answer this question for me? What is the difference between 80 degrees and 90 degrees and 90 degrees and 100 degrees? Who can tell me? What is the difference between 80 degrees and 90 degrees and 90 degrees and 100 degrees? What's the difference? Raise your hand for me. If you are.
So yeah, there's an interval of 10 degrees from each of them. 80.
Oh, sorry. Please go ahead. Unmute yourself and go ahead.
Okay, Prof, there's an interval of 10 degrees. So it's ordered by 10 degrees interval.
Okay. To be honest, the interval is not 10 degrees. You can tell me, what's the difference between 80 degrees and 90 degrees and 90 degrees and 100 degrees? It's zero. The difference between 80 and 90 is 10. The difference between 90 and 100 is also 10. So I'm actually asking you, what is the difference between 10 and 10? Zero. You see, the focus is on the interval, it's not on the numbers. Suppose your friend comes to tell you that, what grade did you get in statistics for business analytics? And then the person asks you, what mark, what score did you get? And he said you got 82. And then your friend started laughing at you because he had 98. Why would you rather laugh at the person? The person asks you, what score did you get? You said you had 82. And he said, that is so bad because she had 98. Why will you actually laugh at the person rather? Salasi.
Doc, because 82 and 98 are all the same grading.
Exactly. They are all within the same interval. That's the point. They are all within the same interval. So these numbers are not numbers on themselves, but they are numbers between numbers. That's it. That leaves us with the last one, which is ratio. Ratio exhibits all the properties of interval. It can be counted, it can be measured, it can be, and it can even have zero. Ratio has the possibility of being zero. So distance can be a possibility of having zero. Time can be zero. For example, when Usain Bolt is about to run, and they said, on your marks, just set. When you look on the board, the number you see is 0.00, which means it's zero. So time can be zero. And there are several situations where things can be zero. When you're doing computer programming, both nominal and ordinal are treated as string. We call them string variables. Just keep that in mind. So when you're doing programming for analytics, okay, these qualitative are called string. And then the quantitative, they can be float, they can be integers. We'll talk about them later. So these are the short exercises I want you to look at. So this is myself, my name, my gender, and all of that. You can see clearly that categorical data are on the left, and then the numerical is on the right. Everything that I've told you, this is a summary of that in myself. Now, let's get to the real reason, the essence of our presence here. And please, by that, you should open your Excel. There are two types of statistics for business analytics: descriptive, inferential. Descriptive, we shall look at it today, so I'm not going much into detail. Inferential deals with probability, parameter estimations, hypothesis testing, regression analysis. In other words, you are making inferences from your data and generalizing the results to others. You are deducing some meaning from a data, and then after that, you now use it to detect something that is not within the data. That is inferential statistics. That's for another day. But for today, in Excel, today, we are going to learn the descriptive statistics of data. The first one, and I'll be asking you some quick questions before. You see, I taught most of you guys, I taught you, I think not all of you, I taught most of you guys ASEX, statistics and mathematics for data science. So let me ask you something. What is the difference between the mean and the median? You can tell me. These are all measures of the location. Location has to do with the center. Location is simply the center of something. The word average is made up of three things: the mean, the median, and the mode. So, Priscilla, go ahead. Tell me.
So for me, the mean can be influenced by outliers in a data set, while the median cannot be influenced by the outliers.
Okay, but what is the difference in their calculation? How do you calculate them?
Okay, so with the mean, you take an average of all the data sets, the data item. But with the median, you arrange them in an orderly manner and take the middle.
Very good, very good. So guys, the mean and the median, they are very much used. When the data has got outliers, which one do you use? Which one is better to use? When the data has got outliers.
No.
Please raise your hand. It will help us not to interrupt everyone. Rita.
It's better to use the median in this instance.
Very good. And all of them are measuring the center. Now, let's look at things measuring the deviation from the center. You can be in the center. I can also be in the center, but there's a bit of gap between us and the main center. The deviation from the center is called the dispersion, the spread, the variability. Oh, by the way, remember that if you want to know more about the mean and the median, you can use the graphs on the right, scatter plot, box plot, histogram. It can tell you a bit about the mean, the median, and all of that. Okay. What about the variance? Well, the spread of the data, the dispersion, the variability, the variation, all of these are measured using the variance, the standard deviation, the range, the interquartile range, and all of that. Let me ask you a question. What is the difference between the standard deviation and the variance? You can tell us. And please, if you don't know, write them down. Write them down. Who can tell us the difference between the variance and the standard deviation? It's a simple difference, which can be indicated by a symbol. John.
So the variance is the square of the standard deviation.
Good. The variance is a square of the standard deviation, which means the standard deviation is a square root of the variance. Either of them is fine. But the standard deviation seems to be mostly used because it's standard. Now, how do you calculate the range? Who can tell us? How do you calculate the range? The range is sensitive to outliers, but how do you calculate the range? If you don't know this and somebody is going to tell you this, yours is to take a pen and paper and write it down. So the next time you too can say it. Salasi.
So the range is the maximum value minus the minimum value.
Very good. Guys, if you don't know, you know. What is the interquartile range? How do you calculate the interquartile range? Of course, that will mean that you need to know the quartiles. How do you calculate the interquartile range? Salasi.
You first have to find the third quartile and then also the first quartile. Then the interquartile range is the difference between the first quartile and then the third quartile.
Very good. Excellent. All of this we shall do. All of this will tell you how deviational the numbers are from the center, but they don't tell you the shape of the deviation. If you want to know the shape, you look at the skewness and the kurtosis. Now, box plot can reveal a lot about skewness and then kurtosis. Probability plot can also reveal information about skewness and kurtosis. Skewness and kurtosis are similar, but they are not the same. We'll find out the difference. Okay, because I'll ask you something later on, but go and find out the difference. Now, I want you to open your Excel. We've come to the real deal for today. Open your Excel. I'm going to do the same thing. That Excel I already gave you. Open it. I'm also going to open mine here. Please confirm if you can see my Excel. Do you see my Excel? This data set is called the pima diabetes data.
Yes, we can see it.
Okay.
Yeah,
Now, at the bottom, I have two sheets. One sheet, at the last column has got English names for the outcome. Then the other sheet, the last column has got not English name, but then it's got numbers that have been used to code the letters. So in other words, it's called dummy variable normally. Anytime a person is diabetic, we give it a value of 1. Anytime a person is non-diabetic, we give it a value of 0. Okay. So this is coding. It doesn't mean that 1 is better than 0 or 0 is better than 1. Okay. Now, Excel is not able to deal with this one, the one you see with English name. That's a categorical. Now, what you have here is not categorical. It's not a numerical. It's still categorical, but it has been coded. So let me give you some advice. You never generate descriptive statistics for categorical variables. I want to repeat that. You don't generate descriptive statistics for categorical variable. Put it down. Don't forget. Put it down somewhere. You do not do that. You do not do that. Okay, let's move on. Please, if you don't understand something, let me know. So we are going to generate descriptive statistics. And by that, what do I mean? Well, those are the ones we just went to, the mean, the median, the mode, blah, 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 all of that. There is an easy way of doing them, and there's a harder way of doing them. Guys, this is Excel we are talking about. So please pay attention and let's see. I'm going to do them down here. And to do that, I hope you've all opened the data set. We need to install data analysis. And when you watch the slides, you know it. Okay. In fact, yes, Eugene.
Sir, please, I don't have the data sets.
I put it in the group. Do you guys have the data set? Can you confirm whether you all don't have the data set?
Yes, we
Sir,
do.
sir, we have the data.
Yes, please, we have it.
Can you put it?
So it's like some of us joined the group after the group was created.
Don't worry, I'll put it there right now.
Yes, sir. Thank you.
Your colleagues are the ones to have put it there. Okay. Anyway, I've just dropped it there for you. You can have a look at it. The data set, then the interpretation of the data is all there. Then the outline. In fact, let me also add the lecture. So you have everything there for today. Let's go to the data set now. Guys, please, if you have opened your Excel, you're going to work along with me. If you have not opened your Excel, you will not be able to work along with me. I need to be sure that I am working with at least one person. Can you raise your hand if you have also opened your Excel? Can you raise your hand if you have opened your Excel? Very good. I have more than enough. Wow, I have around 20. That's good. So click on the tab on the top right. On the top, you will see data tab. Data tab here. Data tab. Data. Click on that data. Please lower your hands. When you click on data, on the far right, you should see data analysis. On the far right, you should see data analysis. If you don't see data analysis, keep your hand raised. If you don't see data analysis, keep your hand raised. Okay. Please follow this 5 steps I'm about to give you, and you will see data analysis. 1, go and click on File at the top left. File. Click on File on the top left. Top left. When you click on File, you will see in the list Options. Towards the bottom, you see Options or Excel options. Click on that. You see Options or Excel options. In the list, this is called Excel option parameter dialog box. Towards the bottom, you see add-ins. Towards the bottom, you see add-ins. Add-ins. You see add-ins there. Click on add-ins. When you click on add-ins in the list, you see analysis 2-pack. I'm not talking about analysis 2-pack VBA. There is analysis 2-pack, not the VBA one. Click on that, and at the bottom, come and click on Go. At the bottom, click on Go. The pop-up will show. This pop-up is known as the add-in parameter dialog box. The add-in parameter dialog box. In that list, you will see analysis 2-pack, not the VBA. You see analysis 2-pack. There's a checkbox. If it is not checked, check it. There's a checkbox on the left. If it is not checked, check it and click OK. Check it and click OK. And now you should see data analysis. Now you should see data analysis. When you click on the data tab at the top, now you should see data analysis. Michael, do you see it now?
Yes, sir.
Perfect.
Thank you.
Now let's move on. At this stage, we are going to click on data analysis on the top right. Click on data analysis. A pop-up will show. That is the data analysis dialog box. The pop-up will show, known as the data analysis dialog box. In the list, you see descriptive statistics. Double click it. In the list, you see descriptive statistics. Double click it. When you double click, a pop-up will show. Okay. A pop-up will show. In that pop-up, there are some things you are going to fill in, and then we will generate descriptive statistics. That will give us the location, the variability, and then the shape of everything you're dealing with. A few things will not show though. Now, look, in the first thing you see is the input range. You see the cursor is blinking in the white space on the right of the input range. The cursor is blinking. That will require you to put in all the data into that sheet. The data starts from here. Guys, this is quite important. You are going to click on the first cell, which is the pregnancy. Then you are going to drag it all the way to diabetes, age. Don't include outcome. Don't include outcome. And then once you drag it all the way from pregnancy to age, you will drag it all the way down to the end. So I'm going to do that. While the cursor is blinking in the white space on the right. Click on pregnancy, drag it all the way. Click, hold, and drag it. Don't release your hand. And keep going down, keep going down. Don't include the last column, which is the outcome. Keep going down, keep going down, keep going down. Now, speed up. Speed up because it's quite a lot. Okay. Speed up. When you get to the end of your hand, keep speeding up. Keep going, keep going, keep going. Okay. And then when you exceed, like I just exceeded, come back to the end. When you exceed, come back to the end. Make sure that your hand is still holding everything. And then once you have taken it from A to H, you release your hand. And so in the input range, you should see A1 all the way up to H769. A1 all the way up to H769. First thing is done. Now, in the descriptive statistics dialog box, click on labels in first row. Click on labels in first row. Click on labels in first row. And then click output range. When you come down, click output range. The moment you click output range, you see a white space, a white box to the right of the output range. Click inside. That is where you want your results to be. Now on the bottom right of your screen, go and click the Excel and scroll up. Scroll up. Don't click the cells themselves. So on the arrow right and arrow left. I'm talking about on this section here. Okay. You will click on that thing here and drag it up so that you will come to the beginning of the work. Once you come to the beginning, move the box, the descriptive statistics box, so that you can see what is in column J. Column J is empty. We want the results to appear in J1, cell J1. So you click inside cell J1. And cell J1 will be collected inside, as you can see, we collected inside the output range. Cell J1 will be collected inside the output range. Now you're done. Click on, now come down and check summary statistics, check confidence interval, okay. Check K to largest, check K smallest. Now, most of the time, you might not need the last three. You only need the summary statistics, which is the same as the descriptive statistics, but I want you to check all for a reason. Now, you are ready to click. Yeah, Magdalene.
So please, the output range, I think I listened to the input to do first, so I lost the output range.
You mean you don't know where to click the output range?
Yes, please.
Okay, so first click inside the white space to the right of the output range like this. It is normally empty like this, right? You see mine?
Yes, please. Yes, please.
So once the cursor is empty there, go and click on the bottom, this point here, this symbol there. Okay. Click on that and then drag it. Normally, if it is down, first you should click inside the box before you do that. If it is down, drag it up. If it is up, that's okay. If it is down, drag it up. And then come to column J and click just the first cell, J1. Click it like I just did. And then the J1 will be collected inside the output range.
Okay, thank you.
All right. Now you check all these checks. Yes, John.
Yeah, so please, I want to confirm the confidence interval, is it always going to be 95%?
That is a default. You can change it when you have a reason to change it, but the default is 95%.
Okay, all right, thank you.
If I'm doing proper research analysis, I know exactly what to do. Okay, so, but I always stick with the default. Now, once you are done, you are going to click OK, and the result of the descriptive will show on the right. This is it. Everything is now showing. Everything is showing beautifully. But the thing looks a little bit weird. So you're going to do something to arrange them. What do I mean by weird? For example, each one will have a mean. Okay. So for example, when you go to this one, it has the mean, here too has a mean, here too has a mean. So that is too repetitive. So what we are going to do is to arrange it a bit. To do that, click on the pregnancies on the column J1, drag it all the way to the right until you get to age. Drag it all the way to the right until you get to age to highlight it. Then do Control X to cut it. Do Control X to cut it, or you can right click on it and choose cut. You can right click and choose cut. Once you have chosen cut, move to column K and rather click there. You're going to paste it in column K, basically. So move to column K, right click and choose paste. or move to column K and do Control V. Okay. You do Control V. That's it. And once you do Control V, you can now see that it is, the headings are above the numbers instead of above the letters. Okay, now you can delete the rest. How do you delete? You go and click on this column and hold your control key down, and you're going to delete the other ones because they are all having mean. Click on N, hold the control key down, keep holding it whilst you click on the P, once you click on the R, because you are removing all of these. You're going to delete them so that everything will be cluttered. You click on the V, your control is still held down. You click on the X. And then once you are done, right click on the X at the top. Right click and choose delete. Right click and choose delete. It will delete everything like I just did. And now, when you go to move to the left, you see that everything is now beautifully shown. Everything is nicely shown. So you have only one column for the mean, and all the means of everything is shown. You have one column for the standard error. Everything of the standard error is shown. The median is shown. The mode is shown. The mode for every variable is shown. The standard deviation, the variance, the ketosis, the skewness, the range, the minimum, the maximum, sum, count, largest, all of these are shown. Everything you have is shown. Raise your hand if you have been able to do up to this level. Raise your hand if you have been able to do up to this level. Please, the solver add-in is not used for descriptive statistics. It's used for linear programming. Okay, let me see. 11 people have been able to, 12 people have been able to do. That's really, really good. Okay, all right. When you go through this video, you can do it multiple times again. Please lower your hands. Now that you have generated this, there are some things that didn't show. For example, we don't have the quartiles. We don't have the quartiles. We don't have the interquartile range. You know, so we got to do those ones separately. We also don't have the coefficient of variation. So how do we get them? By the way, don't worry, we'll interpret all of this. Today is just to show you the descriptive statistics. If you check your Excel, the essence of today's work is to answer some questions. But let's answer the questions first. Lower your hands, lower your hands. Unless you have a question, lower your hands. Samuel, you have a question, go ahead. Sammy, go ahead.
Oh, sorry, what's a mistake? Sorry.
All right, so now, guys, our first question I have here for you. Don't worry, we shall do the others, which is the quartiles and interquartile range later. But the first question I have for you is, how do you get to the end of the data set without scrolling? You remember when you go to the data set, okay, we were scrolling and scrolling and scrolling and scrolling and scrolling. Okay, let me go to the data set and show you. Let me show you. Okay, so this is the entire data set here on the left. How do you get to the end without the data set? How do you do that? Because when the data is plenty, you can't scroll all the way to 100,000 down there. How do you get to the end? Priscilla.
Okay, so you can use the function Control Shift and then the down arrow key to get there.
Be clear, oh, don't just speak anything. Be clear with what you're saying as if you're a teacher. Don't guess.
Okay, so on your keyboard, you have the Control key, the Shift key, and then the arrow keys. Now the arrow key is 4. So you have the left, right, top, and then the down. So you will press and hold the Control key, you press and hold the Shift key, and then the down arrow key, and then it will take you down there.
Okay, that's good. That is one. That's a bit one, that is complex one. Okay, so guys, Control, Shift, and arrow. Okay, if you don't want that, and you do Control, Shift, and arrow right, that will take you to all the things on the right, which is what I did. If you want Control, Shift, and arrow down, that will take you all the way down to the end. That's one way. What's another way, Selassie?
So you press on the control plus the end button on the
Exactly.
top.
So you do Control, and then on your keyboard, press End. It will take you to the end of the data set. Okay. Control and then End. Okay, and then that will take you to the end of the data set. That's it. And if you want to come back, you do Control Home, and that will bring you back to it. This is important, guys. If you don't know, write it down. Okay, next question. How many columns and rows are there in this data? Who can tell us? How many columns are there and how many rows are there? How many columns? How many rows? This is the data. How many columns? How many rows? Forget about the descriptive statistics we have created. From J is not part of it. It's A, column A up to I. How many rows? How many? Are you counting with your eyes? Are you counting with your eyes? You know, you can use the Excel to get it. Suppose the data is 1 million. Are you going to count with your eyes? Again, you can. This is where you can use Control Shift arrow right, Control Shift arrow down. Okay. Control Shift arrow right, Control Shift arrow down. So let's say you are at the corner, first corner. You do Control Shift arrow right. Okay. And when you do that, I highlight it. Now on the bottom, look at the bottom. On the bottom of your screen, it will show count. Okay. At the bottom here, it will show count. So that tells you how many columns are there. And that is 9 columns. Okay. What are they? Pregnancy is 1, glucose is 2, 3, 4, 5, 6, 7, 8, and then 9. Okay. So that is what will give you the columns to be 9. What about the rows? How many rows are there? How many rows are there? Including the headings. Those of you with the data, tell me, how many rows are there? Again, when you click on the pregnancy, which is you can now use the same approach. 769 is the correct answer, Bella. And that is how you get it. Okay, next question. I'm showing you how to navigate around your Excel sheet. How do you show the first or the last 10 records of the data set? If you want to show the first 10 records of the data set, all you do is you still use that same home, control end. Okay, control home, that's what we just did, and we are at pregnancy. And then you can now have this first 10. If you want control end, okay, you click control end, and it will take you to the bottom. Okay, and now that at the bottom, you can now check the 10. First 10 information. That's how you do it. Okay. Now, next question. What is the dimension of the data set? Who can tell me? What is the dimension of the data set? The dimension of the data set is the number of something times something. What is the dimension of the data set? Data dimension for this Excel. Selassie.
So the dimension is the sum or the multiplication of the rows by the columns.
Good. So the multiplication of the rows by the columns. So when we do rows by columns, okay, you'll be able to know. So when you start from here, okay, and then you can move to the top, you'll be able to know. Actually, because I've already created a descriptive statistics, it is seeing them also as cells. If I were to delete them, let me see if I can delete them. If I were to delete, suppose they were not there for now. And all you do is that you click inside and do Control A. You click inside and do Control A. It will highlight everything. And at the bottom, you see the count. Okay. And you will also see the dimension there. So that is 9 times what? What's the answer? You can tell me the answer. Yeah, Frederick. What's the answer, Frederick?
6921.
6921, correct. 6921. And that is what you have down here under the count. When you highlight it, you get that down here. Next question. These are some examinable questions I'll ask you, not here, but in Python. Next week, we'll do Python. Next question. What is the size of the data sets? By the way, highlighting Control A to highlight will also give you the size. The size of the data set. What is the size? Size. The size is not the same. The dimension is just a multiplication. The size is everything. Okay. Who is smart? Oops. Yes, Michael.
Sir, please, when you say the size is everything, does this include both qualitative and quantitative data in there?
Yeah, everything. Everything, qualitative, quantitative, everything.
So what value will come out as the size?
I'm asking you. I'm asking you and you're also asking me. Answer my own first and then. Yes, Professor.
So it's 313,845.
Yeah, explain how you got that. Explain how you got that.
So you go to cell A1. You click on Shift.
Let me show the screen.
Control
It looks like I've moved out. Oh yeah, it's showing now. So you click on what? A1.
You click on A1. Then Control plus Shift. Then you click on the left, right arrow, then the down arrow.
Well, I've already told you that the easy way to do that. I've told you the easy way to do that. And I won't guide.
That's Control A.
Good. Good. In this context, it is every element that you see in the data set. It's every element that you see in the data set. And that is at the bottom. I was not expecting this count, wasn't it? This count. In fact, let me use the other one and see. Okay. I'll use when we come to Python, I'll use the Python that would actually reveal this. Okay. But the size is not exactly the same as what's the one that we did before? Is a number of, the one that we did before was what? Is a rows times column, right?
Yeah, that's a dimension.
That's the dimension, exactly. Okay. So the size is the total number of cells in the data set. Okay. The total number of cells in the data set. The total of the total number of cells in the data set. And one way to get that is doing that control. But I was expecting that it would give us this, but I think it's rather counting. Let me see whether at the bottom you see that. Yeah, normally it doesn't, but it's supposed to be. How many columns did we have?
9.
9. And then how many rows did we have?
769.
769.
769. Okay. Michael, yes, Michael. Don't worry, all of these things are Python questions that I've deliberately brought to, so that I want to get to Python when we are doing it together. Yeah, Michael.
Yeah, so the counts, there's the numerical count and the regular count. And they have different values. So
yes.
So the which one refers to the dimension?
The dimension is the rows times the columns.
So everything, okay. And the size is the same.
The size, ideally, is supposed to be the same. It's not supposed to be the same. It's supposed to be the total number of the item. Now, how many columns do you have? The size is just telling the reader that I have this number, but you are not multiplying them. So the size is telling the reader that is the rows and the columns. Is the rows and the column. And not
all
just
the cells, all the cells in the rows and columns.
Yes, but you're not multiplying them like the dimension. So in this case, it becomes 9 and 769. Is that what they do? Yes, 9 and then 769.
Okay. Yes. Yes.
Okay, let's quickly move on to the next one. Let's quickly move on to the next one. Which are numerical, which are categorical? This one is easy. Okay. So in the data set, which one is categorical? I think which ones are numerical, which ones are categorical? This one is the easiest one. Yeah. Categorical is just, yeah, Priscilla.
So I was going to say the columns categorical, and then the rows are numerical.
Categorical is the last one. It's the one that has no numbers.
Okay.
Outcome. Outcome is the only categorical variable. Everything else is numerical. Everything else is numerical. But if I were to ask you that which ones are float? Which columns are float? Float are those that have decimals. So which columns are float? Samuel.
BMI and diabetes.
Yes, BMI and diabetes are float. So the others are what? Pregnancy, glucose, up to insulin, they are what? They are not float, they are what? Frederick.
I think integers.
Yeah, integers, very good. They are whole numbers. Integers are whole numbers. Let me quickly go to the next one. Okay. What do the summary statistics of the data represent? What do the summary statistics of the data represent? Let me just go back here. The summary statistics of the data, what do they represent? Who can tell us? Well, basically, this is it. They provide information about the values in the data set, like the number of observations, the means, the medians, the standard deviation. Remember, I showed all of these results here. So they are on the right here.
Okay.
Sorry?
Yeah, I was saying the screen was blank, but
is it better now? So what you see on the screen that I've highlighted here, they are the summary statistics. They represent the mean, the median, the mode, and all of those things. So that is what they represent. And then the second question was, find the summary statistics for all variables except the outcome variables. We've done that. Okay. Except the outcome variables, we've done that. So let's talk about blood pressure. Yeah. Let's explain blood pressure. If you look at blood pressure, that is BP, where is that? That is here. What can we say about blood pressure? They have the average blood pressure of these people, John, what would you say of all of these women?
Sorry, actually, I wanted to ask a question.
Right.
Yes, so in an exams, when you say data set and there are multiple sheets in the workbook, are you referring to all the sheets in the workbook or a particular sheet in the workbook?
All of them.
Oh, okay. All right.
Good. So when you take the blood pressure, okay, look at the blood pressure, 72.25, which means that on average, this woman's blood pressure is 72.25. Okay. If you look at the mean and the median, okay, you can see that they are almost the same. Okay. When one is bigger than the other by too much, that is when you tend to see something called skewness will be showing up there. Okay. I'll come back to that. So when you look at the average blood pressure of any pima diabetic patient is around 72. If we were to bring the unit of measurement, we are talking about 72. We are talking about, what do they call it? 72 milligram Hg. Normally, that's how we call it. 72 milligram Hg, something like that. Okay. And what is the minimum and the maximum value? That is a range. Okay. If you look at it, the minimum and the maximum value, oh no. Let me highlight this column we are talking about. The minimum and the maximum value is 24 all the way to 122. It's quite strange that a person's blood pressure is 24. So now the person is not having high blood pressure, but the person is having low blood pressure. Okay. Now, so what does that mean? What does this mean? What does this mean?
Your screen is blank.
Oh. So what does this mean? If you look at the average blood pressure, it means that most of these women are not having high blood pressure. Do you realize that? Most of these women are not having high blood pressure. That is what it basically means. It means that majority of these women are not having high blood pressure. That's it. You know, like, you know, because remember, not all of them are also diabetic. Not all of them are diabetic. So that explains why. Now, what will be the 75th percentile? We'll look at this later when we work with the Python. We'll be looking at the 75th percentile. What about the standard deviation? Let's look at the standard deviation. The standard deviation is 12. The mean is 72. What does that mean? Please note this down. When the mean is bigger than the standard deviation, it means that the data points here, in this case, the blood pressure here, are of similar types. They are all of similar values. That's when the mean is bigger than the standard deviation. And when you look down here, you see that the mean is 72, the standard deviation is 12. Okay, so it means that they are of similar types. But when the standard deviation is bigger than the mean, it means that there's a lot of variation. Okay, it means that there's a lot of varying sizes in the data set, in this case of blood pressure. Okay. When the standard deviation is 0, what does that mean? When the standard deviation is 0, what does that mean? You gotta be incredibly smart to be able to give me this. Selassie.
So it means no variation in the.
It means?
With no variation in the data set.
No. Yeah, but what does that mean? I don't know what you're trying to do. What does that mean? Dela?
It means all the values in the data set are the same.
That's it. That's a better way of putting it. It means that they all have the same blood pressure level. It means everybody has got the same blood pressure level. So if it is 80, 80, 80, 80, 80, everybody has got that. So these are just preliminary analytics that we are doing only using Excel. When we start using Python, we'll do way more than this. And we shall do that next week. We'll do way more than this. So next week, we are going to do this same data set, but this time using Python, and we shall do several things than that. Go and try your hands on how to calculate the quartiles, by the way. If you want to know how to calculate the quartiles, this is how you do it. Control End. All you got to do is, suppose you want to do first quartile, you do equal to, okay? Then you type quartile, okay? Quartile, and then you can highlight the entire data set. And then once you highlight the entire data set, I'm just trying to. Okay. Once you highlight the entire data set, then you do a comma. If it is first quartile you are doing, then will come, you select first quartile. If it is second quartile you are doing, which is a median, you select second quartile. If it is third quartile you are doing, 75th percentile, that's what you are doing. You choose the number 3 and you click enter, and it will give you the value. Okay. And in this case, the value is that. And you can do for the first quarter, you can do for the second quarter, you can do for the third quarter. Then once you've gotten these first quarter, second quarter, the interquartile range is just the third quarter minus the second. The third quarter minus the first quarter. Try your hands on that. We shall do more of this next time, but try your hands on all of this. Ladies and gentlemen, that brings us to the end of the entire caboodle. I'll make this video available for you. You have the slides, you have the everything. If you have any question, please, this is the time to ask me. If you don't have any question, and you'll have a question later, put it in the group page for me. Any question? Dark green. Oh, sorry. Douglas says no. Yeah, you know.
So does that mean that in this particular session or class, we'll be using more of the Excel to do the calculations?
Yes, we use both Excel and Python.
Ah.
Have you guys started programming for analytics?
No, please.
No.
Okay. All of the groups, none of you have started programming for analytics? Because it started yesterday. You know that?
Our first class is today.
We'll have our lecture class today.
Okay, you're going to have your first lecture today. Okay. So I will be using both Excel and then Python.
Okay.
So I'm going to put it on the group page for you on how to download a Python step by step. There's a video I'm putting there. So please, before you come next week, you must have downloaded, installed, and started the first 3 parts of Python before we come. I'll put all of that in a short video for you.
Okay. So we are not going to use hard calculator like.
No, never.
Okay.
Never.
All right. Good.
Yeah.
Thank you.
Yeah. Now you're going practical. You're going applied.
Apply. Okay.
Yeah, no calculator.
Okay. Okay.
Yeah.
All right. Thanks.
All right. Any other question, please? All right, ladies and gentlemen, it's been a pleasure having all of you. Eves, I told you to go and find the difference between skewness and kurtosis yourself. I've given it to you. Go and find the difference, okay? But one has to do with the peakness, and one has to do with, one has to do with the flatness and the peakness, while the other has to do with the deviation from the center. Go and find out the clear meaning. Next week, okay, we will be meeting.